Hi, and welcome to our webinar. We're super excited about this product launch, and I'm going to look forward to spend the next 60 minutes with you on this. And I'm being joined today by Matt Vacanti from GE Aviation. Hey Matt, it's awesome to have you join us.
Hello, Lorenz. As you mentioned, I'm a senior product manager for our advanced and autonomous systems group at our GE Avionics division based in Grand Rapids, Michigan. I have 14 years of experience in the aerospace industry with performance-based navigation, flight data analytics, and commercial drones. I'm excited to be here today to talk about our collaboration and what's next beyond Pixhawk.
Fantastic, and we'll hear a lot more from Matt later today. Remember, this is all live. So for asking questions, please ask them throughout the first half of the webinar, which means in the next 20-30 minutes, so our team can collect them. We won't have time to answer all of them, but we'd like to at least group similar questions, so we'll make sure that we cover the most interesting topics from the audience. Thank you. Then there's another thing. Of course, we've saved the best thing for last. So the most interesting video we'll have will be at the end of the presentation. So stay with us for the next 40 minutes. And we'll have a lot of videos and live demos in between. So I promise it won't be a corporate boring product presentation. With that, I quickly would like to introduce the company. And as part of that, I'd like to introduce myself. I'm Lorenz Meier. I'm the co-founder of Auterion, and I have created 12 years ago a student team called Pixhawk, and that might ring a bell with some of you in the drone industry who have spent the same amount of time with me here. And that is what one of the very popular autopilot systems is called, after the student team. And I did that hardware with a collaborative group of open source developers in 2013. So that's my personal history, and I'm bringing that history into Auterion, which we founded 2017. And we've been working on bringing open source software to the enterprise since, but really based on a very long legacy of activity in the industry, of activity in the open source community, working on all sorts of software for drones ranging from flight controllers to ground stations. Now, Auterion is essentially the enterprise open source drone company. We have the largest dedicated open source drone software team in the industry. We are the largest contributor to PX4 as a single entity, so really invested into open source. We have offices in California and Switzerland where our R&D is located. And we've raised venture capital to really push open source software forward in this industry. Now, one of the things we care about as a company is to A, always leave value on the table to work with partners, and B, to really try to avoid duplicate efforts. And a key part of that is creating standards. So we're driving industry standards. In particular, the Pixhawk Autopilot project has turned into an industry standard. You can think of it as the Bluetooth of drones. And we're working there with key players including NXP, Sony, but also drone manufacturers like FreeFly. Standards really help to avoid duplicate efforts. They avoid having patent lock-in. And we're doing this as part of a collaborative project of Linux Foundation. And that gives us a really strong management component for these standardization efforts. If you're interested in autopilot standards, payload standards, please check out pixhawk.org, and that is where all the standards are covered. Now, something that Auterion particularly makes successful is also we're a trusted government vendor. So many of you might know or maybe not know, but Red Hat Linux is one of the key operating systems used in the US Department of Defense. So open source software is very common in the government overall. And the government likes to use open source software because it prevents vendor lock-in and it helps them to really keep software maintenance at bay and also sustain systems over time. And Auterion, as a company, is providing the ground station to the Army SRR program, so we're already successful in that space and a trusted vendor. What we're not doing as a company, by the way, is any way of weaponized drones or anything like that. So we are focused on providing flight control systems, on providing systems for reconnaissance and similar, but at the core, we're a commercial company. Now, what brings us here today with our new product is a key problem with software in the drone industry, and that is the software complexity is becoming exponential. What that means is that you have over the years accumulated a number of software packages, including flight control, including SDKs and device management and other things, the core autopilot, and each of them grow linearly, so they're all manageable. But the problem is each year there are new requirements, be that you need obstacle avoidance, UTM, compliance, and soon, very soon, certification. And that is really hard to manage as an individual company because it means that all these linearly growing slices form an exponential curve. We're solving that as a company because we're taking the best out of the open source community to which we're contributing and are bringing it to the enterprise, and we're making that accessible. So what we're talking about today is a very different type of product that we have historically not been engaged in. And that has to do with the key observation that the world of flight controllers, mission computers, and connectivity, you can also say the internet, is converging. That is something you need on every drone going forward, and there is no solution today. And with that, we're very proud to introduce our new product, Skynode. So you've already seen a glimpse of what it looks like, but now we're going to look at the real thing. This is our evaluation kit. So this is what you would be getting if you want to work with us as a new customer. And in it, in this box, we have the Enterprise unit. You can see nice bright Auterion orange. And it's really small. It's probably smaller than you thought. It's really, if you know the industry a bit and you know Pixhawk, it's not larger than a Pixhawk. Fits on my hand. It's not heavy. It's a nice aluminum case. And you have all the interfaces you're used to already on it. We'll dive into that in detail. But this is not the only version. So we're actually introducing 3 products today. This is the Enterprise Skynode. This is the Skynode for Government, which has different functionality. We'll come to that later. And this is Skynode RTA by GE Aviation, to which will Matt introduce more details. So this is the hardware platform for software-defined drones. And so let's quickly look into what that means. A drone is a connected autonomous vehicle. So we're thinking of drones not just as something that flies a typical quadrotor. We're thinking of it as something that is a small mobile robotic system. And Skynode and the flight control or robot control software on it, PX4, are capable of driving all these different airframe and vehicle types. So you can use it for all those use cases. And the reason we really did this is because we couldn't find hardware that was able to run our full software stack. And so it makes sense for us to quickly walk through the software stack so you have a good idea of what you're getting. The Auterion software platform is Auterion Enterprise PX4, built around the PX4 kernel, but a lot more, it's a whole distribution, plus the Enterprise Suite, which consists of the mission control system for the operator, pilot, and the suite in the cloud. And we'll look into that in detail. Then we have Auterion Enterprise PX4 on the drone, and then all the integrations and third-party services. Now, Auterion Mission Control is making drone flights more enjoyable compared to standard open source software for the operator, and more scalable for the enterprise, because your pilots are logged in, you actually know what's going on, you know who flew when, where, and it's really easy because these pilots don't need to manage their flight logs manually. So let me quickly switch to the flight control, to the ground station. So this is Auterion Mission Control, and what you can see here is that I've already preloaded a short mission, and the reason for that is I wanted to show you two key things that you might not know from the underlying open source project, Q Ground Control. And that is, one, we have included vehicle models for the vehicles that of the customers we're working with. So you can see as I'm moving a waypoint around here, the trajectory gets updated. And that solves a key problem that VTOL and fixed wing companies currently have, that they don't know where the exact flight trajectory will be. Just a small feature, but it shows really the kind of user experience and polishing we're adding. The other thing that typically is a nightmare is to understand, how does it fit in 3D? Is the mission looking the way I expect it to? Are all waypoints on the right altitude? We've also addressed that problem. So now you're able to look at the mission in 3D, including the pre-planned and predicted flight trajectory. So you can have confidence as an operator to really fly where you plan to fly. Just two small features, small things, but game changers when it comes to the actual operation in the field. And this is exactly what Auterion does. We're building our solution based on open source software, but then we're taking all the rough edges away. So let's go back to the rest of our product. Auterion Enterprise PX4 is built around the PX4 flight control kernel. It's built on stable releases, but we're adding QA on top of it with our own test flight team. We have pilot and fleet management built in, and remote ID and UTM. So with all that, you're getting a complete solution, and not just a very solid kernel that the upstream open source project already is. And on a small personal note, I founded the PX4 project 2011. So long history, long heritage that we're continuing to nurture as a company. Skynode connects payload with the enterprise. That's really its core job as a piece of hardware. It's a central communication hub that connects payload, autonomy sensors, but also the data links, including video link, 4G, LTE, Wi-Fi, to the cloud. That can either be the Auterion Suite, where you have functions that I'll show in a minute, or your own cloud via our cloud API. Now, what is an important part of that is, of course, also to look at the payload lineup. This has been historically an issue in our part of the drone industry for companies that are not vertically integrated. But we're pushing forward with the Pixhawk payload bus standard, and we've won partners, including Sony and others, who are willing to work with us to bring their payloads into the standard. And these are the payloads that we're supporting as Auterion out of the box. And that really makes it simple to build a commercial drone as an Auterion customer. So these are all fully integrated. Now, we have prepared one particular setup, and that is the Sony QX30 that I'd like to show you now in person. So you see in front of me on the table, we have a mock drone, just a landing gear with the camera, gimbaled. We have a Skynode OEM edition. You'll see more about that later. So this is how it looks when it's mounted on the board. It has a data link, it has an RTK GPS. And then we have here a custom ground station by Auterion. You can see we have our logo on there that we have optimized as well for user experience. So you have controls here, but you also have sliders on the side. And these are the ones I will quickly use to show you functionality. Let me keep the screen towards you so you can see what's going on. So one slider is controlling the zoom level of the camera, as you can see here now. And the other slider is controlling pitch. That's of course configurable, but those would be two very typical functions that you need. And so that's a lot better than a hobby remote controller where you have sticks and switches and it's complicated. Users don't like that. And that's all fully integrated. So we can control the white balance of the camera, we can trigger it, we can set the shutter speed, fully integrated on the software level, all available in the UI, and so really easy to use and directly supported out of the box with our software platform. Now, that's interesting and great, but even more interesting in the medium term is our Enterprise SDK. And what this allows you is to run applications on board, in the cloud, or on a mobile device, where you, again, using open source, open standards, and to connect to the systems running the Auterion software. What this means in particular is that you can run onboard applications, something really new in the industry, which connect to the Onboard SDK using a standard called Mav SDK, same thing as the mobile app. And you can control the payload, for example, the Sony camera with it. You can set it up for certain missions, you can set it up for a survey, for example. And then you can directly take that and deploy, for example, captured images to the cloud. So really new pattern, and you can assemble your applications in the form of Docker containers and push them remote from your own GitHub repo. Auterion takes care of all the legwork, will build the application and push it to your fleet. And that's a complete game changer in how you run and deploy software in an enterprise fleet. Now, it's great if you can build your own applications, but there are some pieces of core functionality that almost everybody needs. And we've bundled them in the Auterion Autonomy engine. There are two key functions that we're providing. Number one is not crashing into obstacles, which is collision prevention, which assists the pilot to avoid an obstacle in manual flight. And obstacle avoidance, which essentially reroutes a whole mission around an obstacle. For example, if you forgot that there's this one tall tree in a survey. We also do GPS-denied navigation. And rather than now talk about this at length, I'd like to show it to you. So this is a video where we show the drone comes from the left, how collision prevention works. So you approach the obstacle, the drone automatically brakes. The second sequence here shows obstacle avoidance, where the drone detects the obstacle and then reroutes the mission around it. So it continues to fly the mission, which sometimes is better than just sitting there and hovering. The other key functionality that a lot of customers are asking for, in particular in the government space, but also in inspection cases where you need 100% reliability, is GPS-denied navigation. So we're flying here from an area with GPS coverage into a tunnel, and as you can see on the map, the drone retains its position lock. It knows where it is. It just continues the flight as if nothing were. So we even can switch between GPS and non-GPS environments. This works with various visual positioning sources, and this is another standard piece of our software distribution. Now, we've talked about the pieces for the operator, the mission control application, and we've talked about the onboard software. But let's talk about the really new piece in the industry, and that is the Auterion Suite, which runs in the cloud. It provides product management and support for manufacturers, which means you can think of it as Google Analytics for drones. It's a complete overview of the performance of your product. You can see what's going on, what sort of issues your customers are having, how they're using your product as a drone manufacturer. You can also manage software updates centrally, so you know if your fleet is up to date, and you can even deploy it remotely. And we have included a predictive maintenance engine that will flag vehicles and or flights that seem to have issues before they crash. And so we're changing the paradigm from reacting to a malfunction, crash, or anything like that, to being proactive. So before something happens, when you see telltale signs of a performance issue, you can actually get ahead of the curve. This is a real game changer. Now, for operators, we realize similar value because, again, you have a complete asset and fleet management, so you know how much flight hours your vehicles have, you know how much flight hours your pilots have. We have the compliance tools built in to allow you to export data formats for authorities, and that enables you to really have a seamless execution of your operation. The same predictive maintenance engine is also available to you and will flag vehicles with issues, and then you can resolve those collaboratively with the manufacturer. One of the integrations that is very relevant here is with Zendesk. So if our suite detects a problem with the vehicle, it will actually file a Zendesk ticket with the manufacturer to get support and to get maintenance on it. So I quickly want to show you how this looks like. And I'm logged in here. I'm of course not showing customer data. I'm logged in here into our Auterion QA account. These are the vehicles that are in our small QA fleet here locally. And what we do here is to analyze the fleet level behavior, for example, the travel distance, but also the most used flight mode. So our QA fleet uses missions as the most used flight mode. We also have things that, like, for example, most common failures. So we're flagging individual detections, and you can see how they evolve over time. And as here, you'd like them to generally go down. Of course, this particular fleet is notoriously bad because we inject failures. So don't take that as the performance of the product. This is when we inject failures to make sure we can detect them. But it really gives you situational awareness. You also see it's 8 vehicles. You see how the flights develop. You see where flights happening. And now, if I'm going to flights, you can even see more details here. So, for example, latest flights here were flagged. If we're going, for example, to this one here, this is a test of Skynode, really short test. You can see the suite is now loading the flight data in real time. And so what you're seeing is the ground trajectory, all the details, but you can then also dive into the full log file. But before we do that, you can see on the left all these green icons. They show us that all the checks passed, everything is okay. And now, if you are looking for a particular issue, particular vehicle, or if you're still in product engineering before release of the product, you might actually find it very helpful that you can dive to the full details. You can even read off values here. So you have, we log over 900 variables. You have the most important variables here immediately plotted. I can scroll and keep scrolling and scrolling and scrolling. So you see exactly what's going on. And that's also a very powerful tool already during engineering. With that, let's switch back and get back on topic, and that's Skynode. So what are the technical specs? High level, it's a combined flight controller, mission computer, and connectivity LTE modem. But it's much more because you also have USB peripherals included. You have an Ethernet switch, and you have a MIPI CSI port for a camera. So the highest level summary I can provide is it's a lot of compute with storage, with a lot of connectivity for onboard, for radios, for payload, that allows you to really pull everything together. And that's why we define Skynode as essentially the hardware unit for software-defined drones, because we're connecting all that hardware which is on board directly to one central unit, which allows you to run one consistent application stack. Now, the whole Skynode family includes 4 main units, which is Enterprise, Government, the RTA edition by GE Aviation, and the OEM model, which is the same as the Enterprise model, just without case and with a dedicated heatsink. And let's quickly look into that and understand a bit which one is for you. So for enterprise applications, the Enterprise version obviously is the ideal choice. It's intended for drones and other robots in the 2 kilogram, 4 pound weight category and up. It includes an LTE data plan if you want that. It is designed and manufactured in the US. And we're typically making sure that it's not ITAR controlled, which means that certain functions are a bit limited, for example, flight time or range, because those are regulated by authorities. So that's essentially the main product. And it will also be the first one that is available. And it will be initially available as an evaluation kit exclusively to make sure that you have a known good set of peripherals to run with it. Now, the OEM edition is the same thing. It's the same basic unit without the case, lighter, smaller, with a dedicated heatsink, and it allows you to deeply integrate it into the product before going entirely custom. The Government edition of Skynode is, in terms of performance, very similar to the Enterprise edition. It has one big difference. It doesn't include any software limitations, and the LTE and internet connectivity are optional. That is exactly what government customers need, so you can make sure that your system is offline if you need that to, and it's not restricted in flight times or anything else, because government customers typically are not restricted there. And then on top of that, we're putting it through the required government certifications for cybersecurity, for compliance. It is NDAA compliant, to make sure that as you're integrating it into your system, it is completely safe for usage. If you're interested in that, we have a dedicated business unit, Auterion Government Solutions. Please check out auterion-gs.com for that. Now, something that I didn't have on my table is the Skynode reference design. Now, for volume customers, so when you commit to a significant minimum order quantity, we're making the full Altium files available to you as an OEM, and that enables you to really take the validated base design, modify it, and really run with it and make it your own. That also means you own the supply chain, you have no dependencies in any hardware regard. And that is, again, very similar to the model that other companies, software companies, have chosen. Again, Google Nexus, great example. Now, Skynode RTA, and this is why we have Matt on the call. I'm super excited about this. I've always dreamed about being more close to aviation, and here we go. So, Matt, tell us about it.
Thanks, Lorenz. Thanks. I'm excited to talk about runtime assurance and our integration with the Skynode reference design. There are 3 main points I will be discussing. What is RTA? The functional application within Skynode, and a hardware-in-the-loop simulation demonstration of the solution. Runtime assurance, or RTA, is an industry concept that has been applied to critical software functions and has more recently been implemented as a method to bound the behavior of unmanned aircraft system in the forthcoming ASTM 3269 standard. GE Aviation's RTA implementation, combined with the Skynode reference design, focuses on reducing risk for enterprises conducting advanced operations. Functionally speaking, RTA is embodied within Skynode as an independent hardware and software subsystem that provides high reliability assurance of drone performance through a parallel and dissimilar navigation solution, fully authoritative inline control of actuators and speed controllers, transparent integration and collaboration with Enterprise PX4's existing fail-safe mechanisms, self-contained recovery control functions, and aerospace-grade design assurance. Today, the software and hardware subsystems that comprise RTA are currently functioning on GE's larger custom avionics solution, also running the Auterion software platform. As we transition to the hardware-in-the-loop video demonstration, the functional example I'd like to provide is that of a geofence boundary violation. Ensuring a vehicle stays within an expected airspace boundary is critical to most advanced operations. As the aircraft approaches the boundary, as you can see here in the orange highlighted area, RTA predicts a geofence boundary violation prior to the violation occurring and reaches out to the existing PX4 fail-safe mechanism to change its trajectory. Should the system fail to respond, which we won't demonstrate in this particular video, RTA will continue to increase the level of authority over the vehicle up to and including full control over the actuators and speed controllers. Here we are with the vehicle approaching the geofence keep out boundary. We've received a command to set the aircraft back to the land position, and this could take multiple different factors of change in behavior from the system itself. And the vehicle is now performing its normal landing sequence. And again, as I mentioned earlier, this is a full hardware-in-a-loop demo of the system working and functioning as available today. In closing, I'd like to say that I look forward to our continued collaboration with Auterion. And should you wish to engage further, please reach out directly via Auterion's website or skynode.rta@ge.com. Lorenz?
Fantastic. Thank you so much, Matt. I'm really, really excited. We're working with GE now for well over a year, have really done flights together already. They do a lot of fail-safe testing, which then pops out in our suite as a failure, and then you check the flight log and you see like, oh, it was in a parking lot. Okay, so everything is fine, nobody crashed. So really, really great collaboration, very good spirit, and we think that our very agile open source based commercial off-the-shelf solution combined with GE's knowledge and pedigree in the aviation space is combining velocity of development with the required pedigree for a safe operation of the aircraft. And I think that is really unprecedented, and I think we're going to be able to serve cargo drones and similar use cases, other high assurance use cases together very efficiently, and we're really looking forward to that. Thank you, Matt. Now, with that, we'd like to also cover use cases. That should give you an idea which Skynode is for you, how can you use it, how would it work in your application. Let's start with inspection and mapping. We've already talked about Skynode Enterprise, and we've talked about the Sony camera integration, also other cameras are supported, and the LTE link to the Enterprise cloud. So that is the typical pairing you would use for an enterprise application. Now, for cargo, it's a bit of a different profile. Payload is important, but it's typically not interfaced. So what you do there is you use a Skynode RTA by GE Aviation. You have an FPV camera, maybe or maybe not, that allows you to monitor the flight visually. We have support for that with the MIPI CSI interface. And then because you have an Ethernet switch on Skynode, you can have a lot of data links connected to it, including, for example, a triple redundant LTE setup or an Iridium satellite link, either via USB or UART, lots of embedded interfaces at your fingertip. And then last, for ISR, typically what you would use is a Skynode Government Edition with a thermal plus electro-optical zoom camera. We're supporting multiple models there from NextVision, from Trillium, and this allows you to run then a full ISR mission with one of the typical data links, be that from Silvus or an MPU5 or a microhard link in that application. Now, what we've planned for today is a remote flight, live, real-time. Unfortunately, the weather has really made that really hard. And actually, let me go back one slide. The reason it's not possible is it's pouring here. And we're super excited about the partnership with Quantum Systems on their Vector aircraft because it's a fully weatherproofed system. We think that's also one of the key changes we'll see in this industry. Having bad weather is not going to be a reason to not fly in the future. And we're looking forward to have this system out this summer, make that available, and with that we would be able to fly today. So remote flight, we do not have a live demo, but we have done a trial run yesterday, and you can see in that trial run the full operation with our remote flight. So let's switch to the video. And what you can see here is the screen capture of the ground station running on my laptop yesterday in real time with the team out in the field. You can see the live video feed from the drone, which is currently taking off vertically. It's a VTOL drone with a polar propeller, one of our test aircraft, nothing fancy. And you can see it's pretty bumpy. That was a weather switch from good to bad. However, we're now hovering. You can see the polar was off for a second. And now we're starting to transition in the next few seconds to forward flight. So now the vehicle is starting to go into fixed wing mode with higher bank angles. And we're going to fly through that small mission all the way towards a back transition, and then finally again a vertical landing again. So you can see the vehicle is nicely tracking the planned mission and flying from waypoint to waypoint. Nothing special there other than it works. You can also see we do have a live video feed which allows you to monitor the bank angle of the vehicle. Now it's going into the final turn, and as we're starting to approach our landing point, descending from something like 90 feet or so is not particularly exciting. We're going to look briefly at the piece of the mission planning that I showed earlier already, but which is really, really helpful in this particular use case. So we've now arrived at our landing location. We're going to back transition. We're still using the polar propeller to hold against wind. And now we're switching in the ground station to the mission planning for the mission that we've planned earlier. We're loading it from the vehicle. And as we've downloaded the mission, you can now see, given the current vehicle orientation, this is how the predictor would assume the mission will be executed. And that's really important for VTOL, for cargo operations, because you really need to know exactly where you'll land in flight with the vehicle, and these approximate waypoints are not good enough. This is one of the enterprise level operation functions that we're adding as a layer consistently across the open source platform that we're using and to which we're contributing back. So you can now see if I move a waypoint, it immediately updates the mission, even including loiter commands. And with that demonstration, we're back on the ground. We're done with our trial run from yesterday. Thank you for your attention. With that, we're at the end of the webinar. And now we're looking forward to your questions that you have sent us over the course of the last half hour. So we have 15 questions. We have couple minutes to cover them. And now we have great integration questions, which really shows me that people are thinking ahead, like how could I use that? First one is, how easy will it be to connect various sensors and actuators? So I think the correct answer is pretty easy. Now, the pretty easy statement, I think, depends on two categories. Number one, if you are a system integrator and you're already used to Pixhawk, for example, or you're already used to writing code on Linux, and you have this very special payload you want to integrate, it's going to be really easy because we're an open source company, so you retain all those open source developer degrees of freedom to do that, to bring your own code, to bring your own environment, to change the flight control code if you need to. And so that's easy as a developer system integrator. If you're talking about this from an operator perspective, you're probably not interested to spend code development. You actually want it to work, to just work. And there we have a rich ecosystem of partners, and you can rely pretty much on Auterion and its partners to pre-integrate, for example, the cameras I've shown, but this payload ecosystem will grow. It is against a common payload standard, and that should also be easy. So either you have full degree of freedom if you're a system integrator, or you can go with our pre-integrated set, and we'd like to make sure that it's always a lot easier than it is currently in this industry. The next question is very software heavy. It is about Docker containers. So if you have your own Docker container with image analysis, with an AI algorithm, and can you run this algorithm in the container and feed it images from the payload? The answer is, of course, yes. We've built a system for this purpose. You can even change what the payload is doing. For example, you can tilt a gimbal with software commands. You can change the exposure of the camera or similar things. And that's already prepared in an SDK. So yes, you can get the video stream, and yes, you can change or you can send commands to the camera. Good. Next question is about standards. So will the standards primarily be focused on UAS or also cover small manned aircraft, eVTOL, ultralights? Could a certification be possible for small manned aircraft? I think Matt is the right person to answer that. Before you do that, Matt, I would have a bullish statement, and that is, if this system is flying in thousands of cargo drones soon and working there, isn't that telling you it's working really well? But then there is also a regulatory aspect to that. Matt?
I think it's a great question. And matter of fact, in the collaboration that Auterion and GE Aviation have had over the last year, that's been one of the main things that has been most interesting or most unexpected is that we've had multiple different manned and unmanned aircraft manufacturers and OEMs reach out asking that exact question. And I do believe there's a path there, specifically around demonstrating the reliability and the robustness of the system. Of course, there's multiple different techniques that could be used to accomplish that, but I think in the near term that is primarily focused on unmanned systems.
Cool. Now, the next question is, what software design assurance level will the Skynode from GE meet? I'm also curious about that, Matt.
So I think this is very much oriented around some of the regulatory nature of the question. And initially, we are pursuing an RTCA DO 178 DAL-D level of software assurance. And we have the ability to take that to a much higher level depending on the specific need. But we're targeting that design assurance level in the short term as most likely to meet the nearest term use cases.
Cool. So next question is Skynode open source? Which is a very valid question because I've just told you we're an open source company. So it is not open source for two reasons. So number one, the core reason to create Skynode is to enable our software customers to have a known hardware platform and to have a good experience. Our goal is not to become a hardware company. We're not changing our business model. And as such, we provide this as a stepping stone, the same way as Google has done the Google Nexus phone, for example, but it is not a mainline product that we're pushing into the market as a complete replacement. However, we are equipped to fulfill orders in the hundreds if needed, because we want our drone OEM partners to have confidence into an existing solution. So by all means, yes, this is intended to go into products. It is not a PR stunt. It is not a development tool. It is a fully fledged QA product for real systems. And we're providing that as a starting point. At the same time, we're happy to work with existing avionics manufacturers, including GE Aviation, to work with them so they can launch products that use Skynode and take it to market in the way and with the customer base they know best. The next question is Enterprise PX4 different from the open source PX4? So I would say yes, it's very, very different, but no, it's not proprietary. And it's different because we take a certain version of PX4, we stabilize it, we apply all the enterprise improvements that enterprises care about. We're not taking new risk from new stuff, new drivers, new things we don't need. And then we're providing that to our customers. So usually when you use open source software, you always have the choice between keeping the system as you have it and not getting critical bug fixes and critical improvements, or you upgrade to a new version which induces behavior changes, which induces potentially new issues that you don't know about yet. And we're solving that problem because we're providing a known base, but with all the bug fixes and improvements that enterprises need. And that is exactly what Red Hat is doing for its Linux customers. Now, the next question is Auterion switching to a hardware business model? No, we're not. As I just explained, Skynode is a stepping stone for our customers, our partners, to get much faster to where this industry really should be and needs to be. That doesn't mean Auterion is straying away from its core software model, but yes, we will get any obstacles out of the way that we feel are an issue for our software to create value for the end customer. The flight demonstrated, was that controlled from my laptop? That's the next question. So yes, it was entirely controlled from my laptop in this room here just one day ago because we didn't have the weather conditions today to execute it live. Then the next question is Skynode NDAA compliant? So let me quickly explain what NDAA is. It's the Defense Authorization Act, which essentially means if you're compliant to that, the US government, in particular DoD, can buy from you. So yes, Skynode in all editions is NDAA compliant. However, we generally recommend the government edition because it doesn't have the software limiters that are required for normal commercial users. Then the next question is, where can I order Skynode? Well, obviously on our website. Please check it out. Please fill out the order form. We're currently able to fulfill engineering sample orders. So we're looking at incoming requests where our sales team will reach out to you. And then we're going to open that funnel, make it available to more and more end users over the next couple of weeks. Then there is a question about how much does Skynode cost. That's obviously important. So it depends a bit on the edition. The Skynode RTA with all its safety functions will of course be the top of the line. Then below that will be the government edition because that includes additional certifications that government customers need. We're talking for the government edition around a low number in the thousands. Now for the commercial edition, we do know that our customers are price sensitive. So our target is to have the Enterprise edition well under $800, more with volume discounts. The OEM version will be even lower, and we will be offering, again, don't forget the reference design. So if you have volume as a drone manufacturer and you need to manufacture at a very aggressive price point, you can totally make the supply chain yours, control all of the costs, and that way you can have it essentially as affordable as anyone could get it with your own knowledge and supplier network. Next question is, what is the Auterion software roadmap? That's a very good question because yes, this is a hardware product that we're introducing to the market today, but really it is about enabling software. So we will continue with all the things you've seen today around autonomy, around our mission control ground station, around Enterprise PX4, but what we will in particular focus on are integrations. Integrations with enterprise resource planning systems, integrations with other online services that allow you to really benefit from the connectivity, because this is a true game changer. You can turn your workflows into real-time workflows with Skynode, and we will make sure that a lot of these pre-integrations are available already. Next question, does obstacle avoidance work for fixed wing and VTOL? So in general, from a software engineering perspective, yes, it totally does. The one limitation I would see is the sensor range. So you would need to bring a long-range LiDAR to allow the vehicle to really maneuver around it. But generally, it is something that we have architected in, that is supported, but you will need to make sure you have the right sensor set. So for example, a set of stereo cameras will not cut it. Good. Next question, I just answered that accidentally. Does it support for obstacle avoidance? Does it support 2D and 3D LiDARs? The answer is yes. It's a fully abstracted, layered software system that we're using. So we're generating point clouds from stereo, and we go from there into the navigation solution. So you can by all means use LiDARs, makes your life a lot easier, just has more weight, and it is generally what I would recommend for industrial applications, just because you can make sure that you always see the obstacle, no matter what the lighting is, what reflectance it has. And that's why I personally think with my computer vision experience, we'll see a lot more LiDAR usage, in particular in the enterprise space, because as some of you might know, maybe not all, a stereo camera doesn't work on a white wall, and a white wall is not unheard of in a commercial setting, in a factory, in a commercial building, even outside. And so stereo is very, very challenging for enterprise applications. Next question is a subscription required for Skynode? So I think this question has two parts. Number one, do we sell Skynode without software? The answer is no, because we're not a hardware company. The whole point is to sell our software. And that means that generally, yes, it's always bundled with the Auterion Enterprise platform. Now, generally, we start with a subscription model that allows you to pay by the month, and we have the baseline functionality of the software already included in Skynode. So you buy it, you can use it, no strings attached, but you can add additional functionality, like for example, predictive maintenance as part of a subscription. In terms of other sort of opportunities to structure it, if you are a very high volume customer, we're more than willing to talk through other business models that suit you better in terms of how you get our software, how you might pay upfront or differently. So we're very flexible when it comes to volume, but by default we'll make it as simple as possible, which means you buy Skynode, software included, you can just go ahead and fly, and then if you want more and more of these enterprise features, you can use the subscription packages to upgrade to them. And we'll make that detailed pricing available in the next couple of weeks. Thank you. I think we're at the end of our questions. I hope you're as excited as I am. I think this is not just a really cool product that is solving a lot of problems in the industry, but I do think we've really created a new category of product by taking flight computer, mission computer, and all the connectivity into one package. And that is pretty much not done to this level today, in particular not with the rich software stack we're offering. And so I hope you mark this date in your calendar as a true game changer in the industry, and we're really excited to see where we will all end together with the products that we're building on top of this. With that, many thanks for joining our webinar. Thank you, and have a great rest of the day.